All right, everybody, welcome to Math with Grace. Today we're going to be working through Pre-Calculus, Unit 2, Sections 1 and 2. Section 1 begins on page 5, and it's titled Graphs of Linear Functions. At this point in your mathematical career, you should have some idea of what a linear function is, that it is a line, that it has a variable to the first degree, and that's it. It might have a constant in there as well, but it doesn't have any other variables. That is a linear function. Make sure you're reviewing your vocabulary just so you understand how this book wants things represented. And then let's take a look here at the bottom of page 5. The polynomial functions are groups of functions in this form. Now, this form can be a bit confusing, but it's y equals a sub 0 times x to the nth power. Now, the a sub whatevers, it continues on and on and on, ending with an a sub n. But the a sub whatevers are the numerical coefficients. They could be any number. It could be a 1, it could be a 5, whatever. Each one does not have a connection to the other. They're just labeled a sub something. Okay, the fact that this one ends with an n, it really means almost nothing. Okay, it's just to denote one numerical coefficient from the other, right? N is a positive integer. It's the exponent of the variable x. So in a linear function, right, our exponent is a 1. That's it. So it would be like way over here at the end of the group. For a linear function, all of that we don't need. We just need this last little bit down here. If a sub 0 equals 0 and n equals 1, the expression is a linear equation or a linear function. Or sorry, not equals, is not equal to 0. A sub 0 has to be not equal to 0, and n equals 1. So we're talking about like way over here, but starting here is where they start, but then all of that would be gone except for maybe this number at the end, maybe not. It's called a first degree polynomial. We'll look at these. This equation can be confusing. Like I said, we'll look at it in simpler terms in a minute. Okay, y equals mx plus b, where m cannot equal 0, and where m and b are constants is, it says here the standard form, but it's really the slope intercept form. Let's turn the page and keep talking about linear functions. Here on page 6, some examples of a linear function are y equals 3x plus 2, x plus y equals 6, and 7x equals 3y. And so then for practice, they want you to identify the a sub 0, a sub 1, and n. So for this first number 1, here your a sub 0 is 3. It's the coefficient of your variable. The a sub 1 is the other constant in this equation. And your n, or your exponent, is a 1, right? X to the 1 power. Now to figure out number 2, you have to rewrite this in a y equals form. You have to write it in our slope intercept form, y equals mx plus b. It's the only way to figure out what these points actually are. So this one is y equals negative x plus 6. So our a sub 0 is a negative 1 because this is a negative 1 in front of our x. Our a sub 1 is 6, and of course our n is going to be a 1 because these are linear equations. And then same thing here, we have to rewrite this as a y equals by dividing both sides by 3. So y equals 7 over 3x. So for our a sub 0, it's 7 over 3. Our a sub 1 this time is 0 because we don't have a plus b. But our n is still to the 1 power, okay? It's important to remember that the graph of a linear function is a straight line, but not all lines are linear functions. A vertical line is not considered a linear function, because remember, if we're talking about a vertical line, all of the values of y have the exact same x, and so that's literally the definition of not a function, right? So, example here, graph, make sure I'm on the page, x plus y equals 2, and find at least 3 solutions. So we have to solve for y. We need it in our y-intercept form. Then we can choose 3 solutions, and whichever 3 you choose are fine. And you plug it in, right? You substitute 1 into here becomes a -1 plus 2 is a 1. If you put a 0 for x, 0 plus 2 is 2. And if you put a 2 in here, then it becomes a -2 plus 2, which is 0. They plotted their 3 points, connected them with a line, and that is the graph for this equation. All right? Now we're going to start talking about zeros of a function up here at the top of the second column. Zeros of a function are the value of x for which the function is 0. Thus, the zeros of the function are roots or solutions, where f of x equals 0. Where did f of x equal 0 on this one? When x was 2. X equals 2 is the root. Okay? The x-intercept is the point where the line crosses the x-axis, and the y-intercept then is the point where it crosses the y-axis. The root, the x-intercept, and the 0 of the function all refer to the same point. Okay? It's this point here. They all mean the same thing, so we can use these terms interchangeably. Root is probably the one I use the most, or 0, but I guess we'll find out as we continue on. Usually we say intercept when we are talking about a graph, and root or 0 when we are finding the values just algebraically. Okay, when we are just doing algebraic math and not graphing something, we would say root or 0. When we are graphing, we would probably say the x-intercept. Okay, continuing. Solving linear equations that include fractions, okay, such as graph y equals x squared minus 9 over x plus 3. It's implied in this rule that x cannot equal 3. Therefore, the domain of this function is the set of all real numbers except x equals -3. Remember, we have to find the undefined value that would make this whole equation undefined, and that is at x equals -3. After that, we need to factor. Remember, our favorite F word, factor, factor, factor. X squared minus 9 is a factorable term, okay? And it factors to x minus 3, the quantity x minus 3 times the quantity x plus 3. Once we do that, we can actually cancel our x plus 3's. And so we end up with y equals x minus 3. That is pretty easily solvable here at the top of page 7. Since y equals x minus 3 is a straight line, and don't forget your excluded value, x cannot equal 3. We have a line with a hole in it, okay? And so they've chosen a few points, and they have plotted their line. But when you plot the line, you have to remember that x cannot equal a -3. Therefore, there's an open space. There's a hole in our line. All right, so within reason, when we graph a line like this, we need to make sure that we graph that open hole so it is visible on our chart, okay? Now it says here that for the further you go in calculus, probably not in this curriculum, you will figure out how to see how close it gets, because it actually gets super, super close to being a -6, probably a -5.99999 and a -6.00001, but the actual -6, it cannot be. But it gets really, really close, and you'll learn how to do that in a full-on calculus class. Okay, that's the first part of section 1. Go ahead, let's take a look at some of these problems together. We'll start right here with problem number 3. It says find 3 solutions for the following linear function and use them to draw its graph. Now, I'm not sure how well this shows up on the video, but there is a super light little piece of graph here that we will use. Hopefully you can see it on the video. If not, if you have the book, then hopefully you can see it in your book. I mean, it's very, very light, but it's there. So we are looking for 3 solutions, and we are going to draw the graph. Our function is f of x equals x plus 3. The basic solutions that I'm probably going to use here are -2, 0, and a +2. So when x is -2, I have -2 plus 3. So my y is 1. When x is 0, I have 0 plus 3. So my y is 3. And when x is 2, I have 2 plus 3. And so my y, or my function, is 5. Okay? Let me set up this graph. All right, now that I have my graph set up, and if you can find a small ruler like this, usually they come with like geometry things, compasses and whatnot. They're perfect for these workbooks because they fit on the page really well. So now that I have my axes set up, my x and my y axis, I can plot my points, right? My first point is at -2, 1, which is right here. The next point is at 0, so I'm not going anywhere with my x, +3 for y, 2, 3. And my third point is at +2, +5, which is here. Okay, take my ruler and draw my line. All right, so that is the graph for the function f of x equals x plus 3. All right, let's turn the page and look at some more. Let's take a look at number 5. For number 5, it says, find 3 solutions for the following linear function and use them to draw its graph, right? They want us to do the inverse f of x if f of x is x plus 3. Well, remember, for the inverse, we simply switch the x and the y. So my y is going to be equal to x minus 3, all right? So that's the inverse function. That's what they want us to solve and graph. So now let's choose our points. Again, I'm going to choose -2, 0, and 2. Let's make this as simple as possible. We don't need to get crazy with our graphs, right? Let's just keep it simple. So -2. When x is -2, I have -2 minus 3, or -5. When x is 0, I have 0 minus 3, or -3. And when x is 2, I have 2 minus 3, or -1. All right, let me set up my graph. Now that my graph is set up, let's plot our points. I am at -2 and -5. 1, 2, wow, it's so light. 3, 4, 5. Brings me to here. I have 0, -3. 2, 3. And I have 2, -1. And that's right about there. And there we have it. There is that line for the inverse of the function f of x equals x plus 3. Okay? Let's take a look at number 7. For number 7, it says, what are the y-intercepts of g of x if g of x is equal to 3x minus 2? Remember, when we solve for a y-intercept, all we need to do is make x equal 0. Because when x is 0, right, it's not moving off of the y-axis, and that's what we're looking for. So y is going to equal 3 times 0 minus 2, or y is equal to -2. So the x-intercept is, or sorry, the y-intercept is at -2. Or if you wanted to write the coordinate point, 0, -2. Okay? Let's take a look at number 9 next, at the top of page 9. For number 9, it asks us to find 3 solutions for the following linear function and use them to draw its graph. This time, though, we have a fraction, right? So we definitely have an excluded value. And our excluded value is that x minus 4 cannot equal 0, or x cannot equal 4. So now we know what our excluded value is. We need to factor. X squared minus 16 is a perfect square binomial. So it becomes x minus 4, x plus 4 over x minus 4, right? Now, remember, we can only cancel in groups whenever we have a plus or a minus in between. Then those two terms are bound together forever and ever. Linda and Heather, best friends, okay? So we can cancel like this. Now, we have our function y equals x plus 4. That is what we are graphing, okay? So let's choose our points. Let's choose the points, -2, 0, and 2, let's say. So when x is -2, I have -2 plus 4, or 2. When x is 0, I have 0 plus 4, which is 4. And when x is 2, I have 2 plus 4, 2 plus 4, which is 6. My brain going a little too fast, okay? Now we can plot our points. While I was on a little pause break for the fire alarm going off in town, I went ahead and set up my graph. So my first point is at -2, +2, which is here. My second point is at 0, +4, which is here. Again, these graphs are very, very light, so I'm sorry if you can't see it, but we're doing the best we can here. And then I'm at +2, +6. Now I said when I was talking about this, within reason, we want to make sure we put our excluded value on here. Pardon me. So when we go to draw our line, we need to make sure when our x is equal to 4, or when it hits the 4, it would be 4 plus 4, which is 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be right here that we draw our little open hole. And so we're going to connect our lines, and then I want to go a little bit past it to show that my line goes on and on forever, amen. It doesn't stop at that open hole. It does continue on, but that is our excluded value, so it is a hole in our line, okay? Let's take a look at number 13, which relates to number 9. I'm trying to keep them both on the page at the same time, a little bit at least. So number 13 reads, what is the y-intercept of h of x is x squared minus 16 over x minus 4? We can see what the y-intercept is right here, right? We solved for it right here. When we set x equal to 0, we solved for the y-intercept. So the y-intercept is at 0, 4, or +4. All right, go ahead and finish the rest of these problems, and then we will go on to the next part of section 1. The next part of section 1 starts on page 10. It's called Equations of Linear Functions. Again, we have some vocabulary to review. And then the bottom of page 10, it starts talking about how some of these equations were come about, but let's just take a look at what these equations actually are here on the top of page 11. If delta x is what they call that, right? I call that the change of x, were 0. The denominator in the slope formula right here, right? If this were a 0, the denominator would be 0, which means that this slope would be undefined. And undefined slopes are slopes of vertical lines, okay? They just go straight up. So reviewing the slope formula, we have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, also, or delta y over delta x, the change in y over the change in x, okay? Looking at this example, we have 2 points, 5, -7, -3, 9. So we need to determine which is 0.1 and which is 0.2. They've done it for you here by labeling this 0.1, 0.2. If it helps you to label your x and y, then go ahead and do that. So this is x sub 1, y sub 1, x sub 2, y sub 2. And then you simply substitute those values in for your slope formula. So my y sub 2 is 9 minus my y sub 1, which is a negative 7. So minus 7. Remember, this negative here is part of the equation. That negative there belongs to the 7. All right? So it has to come along. But can we have a minus in math? No, of course not. So it becomes a plus. Okay? For my denominator, I have x sub 2, which is a negative 3, minus x sub 1, which is positive 5, so minus 5. And now we do the math. 9 plus 7 is 16. Negative 3 minus 5 is a negative 8. So my slope is a negative 2. They use m, the letter m, to represent slope. I'm not exactly sure why. It's just something you need to get used to. Okay? It says here that if you know 2 points in a line, you can use the 2-point formula to find the equation of that line. I've always called this the slope point formula. They will call this the slope point form or point slope form here. But for some reason, they're calling it the 2-point formula in this moment. And the 2-point formula, or the slope point or point slope form, is this. Although we commonly see it written like this: y minus y sub 1 equals m, the slope, times the quantity x minus x sub 1. Okay, here they've just written out what the actual slope formula is instead of the m, but I feel like the m makes it a little cleaner and a little easier to understand, which is exactly what they've done here as well. Y minus y sub 1 equals m times the quantity x minus x sub 1. Point slope form. Let's take a look at the example that they give us here. Example 2. Find the equation of the line containing the points negative 1, 2, and 4, 3. Now they're doing this all at once. I personally would probably have solved for the slope on its own and then just plugged it in here. But they're solving for the slope, 3 minus 2 over 4 minus 1. Now we can't have a minus in math, right? So it becomes a plus. So I have 3 over 2, which is 1, over 4 plus 1, which is 5. So our slope is equal to 1/5. Now we can plug this in here, and here's how this formula works. We're going to choose a point. They chose the point negative 1, 2. And you're substituting that in for the y sub and the x sub. This x and that y never change. They are always going to be an x or a y. We are substituting in here for the subs. All right? So we have y minus 2 equals 1/5 times the quantity x. It was minus 1, right? But we can't have minus, so it's x plus 1. Now, to get rid of this fraction, because we don't really want to multiply this fraction through and have to deal with that, they multiplied every term by 5, okay? So you got 5y minus 10 equals x plus 1, right? 5 canceled here, and all we're left with is the x plus 1. Then they put it into standard form, which is combining our constants and putting our x and y on the same side of the equal sign. So we get x minus 5y equals negative 11. And that is the standard form of a linear equation. Right? So, point slope form. Let's take a look at another example. It says, find the equation of a line containing the point 2, 3 and having a slope of 3. So this time they've given us the slope, which is great. And they've only given us 1 point, which is fine. We can put it into our slope point form and solve. So we have y minus 7 is equal to m, or 3, times the quantity x minus 2. And then we simply solve. This time, we are just going to distribute our 3. So we get 3x minus 6. So they have written y equals 3x plus 1, or negative 3x plus y equals 1. The way they organize these things sometimes, I don't see the pattern, but that's okay. Either one of these, this is standard form, this is slope-intercept form, either one of those is fine. All right, let's turn the page. So at the top of page 12, it says using intercepts to find the slope. It says if the point you are given happens to be a y-intercept of the line, finding the equation is even simpler. So if they give you the point 0, comma something, you can just simply plug it right into the slope-intercept form. So let's take a look at what that means. Here is our example. Find the equation of the line with a slope of 3/4 and a y-intercept at 0, comma -2. Well, if we know that the y-intercept is at 0, comma -2, we can just plug it right in here because this b in the slope-intercept form represents where we cross the y-axis, the y-intercept. So the equation of the line is simply y equals mx, well, my m is 3, so 3/4 x minus 2. That's the equation. That's why they're saying it's the simplest way, because m is the slope in this formula, and the b represents the y-intercept, where we cross the y-axis. Then they changed it to standard form by multiplying every term by 4. Remember, with standard form, we don't want fractions. And then we also want our x and y on the same side of the equal sign. So that's what they did. The next example here is given the line having the equation 2x minus 3y equals 5, find the slope and the y-intercept. To do that, we simply need to move this into slope-intercept form, and then we'll have all the information we need. And so they've done that here. Y equals 2/3 x minus 5/3. 2/3 is the slope, and the y-intercept is at -5/3, so 0, comma -5/3. That is the beauty of the slope-intercept form. It's why we use it so much. It gives us so much information in such a simple equation. All right. Up here, it tells us that the x-intercept is denoted by A and the y-intercept by B when we're talking about these forms, these generic forms where we have A's and B's and whatever, that the x is A, the y is B. So this is the generic form. Bx plus ay equals ab, a times b, okay? And as long as a is not 0 and b is not 0, you can divide by this ab and get the following. Now, of course, they reduced, but it's x over a plus y over b equals 1. This is called the intercept form, okay? So x over a plus y over b equals 1 is called the intercept form. And it says here, if a line passes through the origin, both the x and the y intercepts are at the point 0, 0. And it says not only does this not work in the equation of the intercept form, it also doesn't provide enough information to define a unique line. Many different lines have this same intercept. Many different lines, an infinite number of lines, pass through the origin point of 0, 0. Okay, so this is the intercept form. I believe there's an example coming up for that, but they want to go over one more formula real quick, and that is the midpoint formula. To find the midpoint between two points, okay, we use the formula, and this formula is pretty specific to intercepts, okay? So this is what it would look like if you had the x-intercept and the y-intercept and you wanted to find the point in between them. It would be a plus 0 over 2 or a over 2, and b plus 0 over 2 or b over 2. The regular midpoint formula for any 2 points, okay, is x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. Okay, you're basically finding the average of the x values and an average of the y value, and that becomes your midpoint. Okay, so that is the generic basic formula. This one is very specific to having the intercepts, because that's why they're talking about intercepts and they're talking about the midpoint between them. So let's take a look at the example then at the top of page 13. It says the point 3, 2 bisects the portion of the line that is cut off by the coordinate axis. Okay? The portion of the line cut off by the coordinate axis is this portion of the line. 3, 2 is the center of that line, and they want you to find the equation of that line. So it says A is the x-intercept and B is the y-intercept, and the point 3, 2 is the midpoint of the line segment joining A, 0 and B, 0. Applying the midpoint formula, it would look like this, right? 3 is the answer for A over 2, and 2 is the answer for B over 2. Now, solve for A and B. Well, to solve for A, you would multiply both sides by 2. To solve for B, you would multiply both sides by 2. So A equals 6 and B equals 4. Remember, A is our x-intercept, so 6, 0, and B is our y-intercept, so 0, 4. Right? Now, knowing that, you can solve for the equation. So using the intercept form, which is this, you can solve for the equation. Remember, the intercept form is right here. They put in their A and their B. And then to solve, you have to find a common denominator, which is 12. Multiply every term by 12. So we got 2x plus 3y equals 12. And then what are they asking us? Find an equation of the line. So this technically is the standard form of the equation. They've gone the extra step in changing it over to slope-intercept form and then listing the slope and the y-intercept, which we already knew what the y-intercept was. But it said find an equation of the line. This step is fine. You don't have to go any farther than that. Now, what they have here on page 13 is pretty nice. It's a little review of the different forms, okay? So this 2-point form and the point slope form are literally the same thing, okay? Except they've just spelled out what m is equal to. Then we have the slope-intercept form, the regular intercept form, and the midpoint formulas, which they wrote like I wrote over here. Okay, so these are the basic midpoint formulas. These two that they have here, like I said, are very specific to having the intercepts. It's not always the case, so we can't lean on that specifically. Let's take a look at some of these problems. Starting with number 16 here, it says find the slope of the line that goes through 2, -3 and 4, 3. Remember, our slope formula, which they actually didn't list here, but it is right here, okay? So our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's what we're going to do here. Here's my x1, y1, x2, y2. Okay, so I'm going to have 3 minus 3 all over -4 minus 2. Now, I can't have a minus in math, so it becomes a plus. And I end up with 3 plus 3, which is not 3, which is 6, over -4 minus 2, which is a -6. So my slope is equal to 6 over -6, which is a -1. Okay? So letter A is the answer for that. Find the slope of the line through 3, 4, and 0, 2. All right, same process, right? Let's say x sub 1, y sub 1, x2, y2. So we have 2 minus 4 over 0 minus 3. 2 minus 4 is a -2. 0 minus 3 is a -3. Negative tells me it's a positive 2/3. So B. All right, let's turn the page. Problem number 18. It says, write the equation of the line with a slope of -4 that passes through the point -2, 3. All right, so we are using the slope point form. So it's y minus y sub 1 is equal to m times the quantity x minus x sub 1. All right, they've given us the slope and a point, so we're just going to put it in. Y minus 3 is going to be equal to negative 4 times the quantity x minus minus 2. Okay, we can't have a minus minus in math, so it becomes a plus. I need to distribute my negative 4, so y minus 3 is equal to negative 4x minus 8. And they want this in the y equals mx plus b, this slope-intercept form. So I'm going to add 3 to both sides, and I get y equals negative 4x minus 5. Okay, negative 4x minus 5 is A. Taking a look at number 19, write an equation of the line that passes through the points 3, negative 1 and negative 2, 5. Well, I'm going to need to know the slope formula. And so first I'm going to solve for the slope. I like to do it in 2 pieces. If you want to do it all at once in that, what was that form called? The 2-point form, go ahead. I like to do it in 2 pieces. That's just my preference. So first, the slope is going to be 5 minus minus 1 over negative 2 minus 3. Okay, minus minus 1 becomes a plus. So I have 6 over a negative 5 for my slope. All right. Now I can use my slope point form. So let's choose the point. Oh, none of these points are great here. I like to choose, I know my slope is going to be multiplied by my x, so I usually try to pick a point where that will help get rid of this fraction. But none of these are going to do that. So I guess I'll just pick the first point. So y minus minus 1 is equal to negative 6/5 times x minus 3. This becomes a plus, so I have y plus 1 is equal to distributing my 6/5 x minus, oh gosh, 18/5. That's stinky. Well, they have this written in 2 different ways, so let's go ahead and at the very least clean up our terms here that can be combined, because we need to subtract a 1 from both sides. Now remember, when we're subtracting a 1 from a fraction, we're actually subtracting 5/5, right? So y is going to be equal to 6/5 x minus 18 minus 5/5. So negative 18 minus 5 is 23/5. Okay, so neither one of these is correct. If we multiply both sides by 5, every term by 5, we get 5y is equal to 6x minus 23, which is letter A. All right, I prefer if they just told you what form to put the equation in, but whatever, we know what we're doing, so we can solve these. Let's take a look at number 22. What is the slope of the line defined by this equation? Okay, well, assuming that b cannot equal 0. To solve this equation for the slope, we need to solve for y. So first things first, we're going to subtract the ax from both sides. So I have by, and we're going to subtract that c from both sides. By is going to equal negative ax minus c. And then I need to divide all of the parts by b. So y is equal to negative a over bx minus c over b. Okay? So our slope always comes as the coefficient of our x, so it's negative a over b, so it's letter A. Okay? Negative a over b. Looking at number 23. What is the x-intercept of the line defined by this equation? Okay, the x-intercept. So when y is equal to 0, what is the x-intercept? So considering this is now a 0, I'm going to solve for x. So I have ax is going to equal a negative c. Dividing both sides by a, I get that x is equal to negative c over a, which is right here, letter C. Negative c over a. All right, now let's do one with an actual equation. What is the slope of the line defined by this function? F of x equals negative 2/3 x minus 4. Remember, the slope is always the coefficient of x. So the slope of this is a negative 2/3. That one was easy enough. All right, so go ahead and finish these on your own. We are not going to be doing this, if you're in my class, we are not going to be doing this self-test. I'm going to have a test for you, but go ahead and finish this bit of section 1, and then we are going to move on to section 2. Section 2 begins on page 17, and it is titled second degree functions. Okay, so solutions to second degree functions. It says algebraic functions of the second degree is called a quadratic function and is generally denoted as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. Again, there's a little bit of vocabulary to review. And then we're going to look down here at the zeros of second degree polynomial functions. The graphs of second degree functions are curves called parabolas. Okay? Parabolas can cross the x-axis once, twice, or not at all. This means that a quadratic function may have 0, 1, or 2 real roots. All right, let's turn the page. Here at the top of page 18, the solution of f of x equals ax squared plus bx plus c when f of x equals 0 are the zeros of the quadratic function. Let's take a look at this example. X squared minus 7x plus 10 equals 0. This is factorable, so that's the easiest way to solve this particular quadratic equation. So they factored it. When we factor this, we set each piece equal to 0. So x cannot equal 5 and x cannot equal 2, or those are the zeros of this equation. Okay, so these two solutions are the roots of the original equation, and they put it in a solution set. This is not an ordered pair. It's just the numbers 2 and 5 in a set of brackets as a solution set. Okay. The next example, find the roots of this function, 2x squared minus 5x minus 12. The roots are values for which f of x equals 0, so they set this equal to 0. They factored it, okay? And then they set each piece of the factor equal to 0 and solved. So they got x equals negative 3 over 2 and x equals 4. So these are the two actual points where the zeros are. Here they just listed the solution for the x values, but here they've actually listed the coordinate points. At the top here, back at the top of 18, the second column, it says using the quadratic formula. So here we factored to solve, right? But not everything is factorable. Sometimes we have to use the quadratic formula. We can use the quadratic formula anytime, honestly, even if it is factorable. It's really just a matter of choice. So to use the quadratic formula, we first have to put things in standard form, which means we want all of our terms equal to 0. And then we can list our a, b, and c terms and then plug them into the formula that's right here. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Do not forget the over 2a part. So they have this one, solve 4x squared plus 5 equals 21 using the quadratic formula. We need to move this 21 over to the left-hand side, so these are all on the same side of the equal sign, equals 0. And then we know that our a is the coefficient of our x squared. Our b is, so this is supposed to have an x here. Hold on, let me grab a regular pen if I can get one. Seriously? Here we go. So this is supposed to be a 5x. So make that correction in your book. So the b term is the coefficient of the x value, and the c is the constant. So a equals 4, b equals 5, c equals negative 21. Make sure that term sticks with whatever, or the sign, sorry, sticks with whatever term it's supposed to be with. And then we simply substitute the values in, solving and reducing until we get to here. And then we see that we have two possible answers. Sometimes we can leave it in this form, but because 5 and 19 are like terms, we need to combine them. So we have negative 5 plus 19 over 8, and we have negative 5 minus 19 over 8, and that's how we get our two answers. Because remember, if our equation has an x squared, then it has two answers. Sometimes those answers are exactly the same, like negative 3 and negative 3, but not always. All right, so we need to make sure we solve and get our two answers. Looking at the top of page 19. Our example here is x to the 4th minus 11x squared plus 28. Now, they are going to continue to use the quadratic formula for this. And, or actually, they're not using the quadratic formula. Sorry, they are factoring. Oh, they do use the, okay, I was going to say, I thought I read them use, this is a different example, but this is factorable because our x to the 4th is an x squared squared, right? And so that allowed them to factor it to look like this. And then they solved, because they had to take a square root though, it's a plus or minus, okay? Because when we take the square root, remember we have two answers, which makes sense because this is an x to the 4th, and therefore we should have four answers. Okay, and it says here, notice that this equation actually has four solutions. It's because it's not really a quadratic function, it's a fourth order equation. And so the highest power was 4, we should have four answers. Okay, now it says here to solve this with the quadratic formula, they've replaced the x squareds with a z, which is why it says z squared, because remember it's x squared squared. So z squared minus 11z plus 28 allows us to have our a equal to 1, because remember, even though this z squared technically doesn't have a coefficient, or it doesn't look like it has one, right? It's got that invisible 1. My b is negative 11, my c is 28. They put in all of the information, solved, got to a certain point where z is 7 and z is 4, but remember, my z replaced x squared, so then we had to x squared equals 7, x squared equals 4. We've had to substitute that back in, and we ended up with the same four answers. Okay? All right, let's do some of these problems together. Taking a look here at problem number 3, they want us to solve the equation 6x squared minus 5x equals 50 by factoring. First thing we're going to do is rewrite it as 6x squared minus 5x minus 50 equals 0. Now, they want us to factor. It's listed right here. Because this has a coefficient, our quadratic term has a coefficient larger than 1, it makes it a little bit tricky, but let's review a method that we have used in the past. And so 6 times 50, technically negative 50, remember we take this one and we multiply it by this one, gives me a negative 300. And then I need to look what factors of negative 300 are going to add together to give me 5. All right, so this is where we have to kind of flesh it out, right? Because 30 and 10 is not enough. So let's see here. I have 300. What about divided by 15? What does that give me? 15 and 20. All right, boom, we hit it on the first go. Now, my 20 needs to be the negative. My 15 needs to be positive. That's the only way I'm going to get this negative 5, right? And then how do we want to combine these? So I'm going to combine the 15 with the 6, so 15x, minus 20x minus 50 equals 0, right? And then remember, we're grouping these together. This is going to be a plus in between here, though, that's not multiplying. Now, what do these two terms have in common? Well, they have a 3 and an x in common, right? And so that's going to be 2x plus 5. And then what do these have in common? They definitely have a 10. Do they have anything else? No, and it's negative. So let's say negative 10 is going to be 2x minus 5, or plus 5 this time because I took out the negative here, equals 0. Now I have 2x plus 5 in common with these two terms, and that leaves behind a 3x minus 10 equal to 0. All right, so we are almost done. I have 2x plus 5 equal to 0, and 3x minus 10 equal to 0. I need to solve each one. So 2x is equal to negative 5, x is equal to negative 5 over 2, and 3x is equal to 10, x is equal to 10 over 3. Okay, so my two solutions are negative 5 over 2 and 10 over 3. So this one right here, B, letter B. Okay, so if you don't remember how to factor when we are looking at a problem like this, go back and watch this section again so that you can refresh your memory one more time. Maybe there's another one on the next page coming up, but we'll see. Let's turn the page for now. All right, let's take a look at number 4 here. It says solve the equation 9x squared minus 16 by factoring. We got it kind of easy here because this is a perfect square and this is a perfect square. So we have a perfect square binomial, which tells me that I'm going to have a sum and difference binomial when this is over. And I want to take the square root of this, which is 3x. And I'm going to take the square root of this, which is 4. Okay, and then because they are very similar, we're still going to set them up both equal to 0 because we have two pieces, right? So here I have 3x is equal to 4, so x must equal 4/3. And here I have 3x is equal to negative 4, so x is equal to negative 4/3. And so our answer is B, plus or minus, right? Plus or minus 4/3. All right. Let's take a look at number 6. For number 6, it says solve the equation x squared plus x minus 1 using the quadratic formula. All right, remember the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's identify our a, b, c. My a is equal to 1, coefficient before here. My b is equal to 1, the coefficient here, and my c is equal to negative 1. Okay, let's put it into the formula. I have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1, all over 2 times 1. Okay, so negative 1 plus or minus the square root of 1 squared is 1. Negative 4 times the negative 1 is 4. So positive 4. 4 plus 1 is 5. All over 2. They try to trick us with this I, but we don't have a negative under our radical, right? It became positive here because we had a negative times a negative. So our answer is C. All right. For number 7, solve the equation 4x squared minus 2x equals 7 using the quadratic formula. We need to rewrite this as 4x squared minus 2x minus 7 equals 0. If you do not rewrite it, you're going to have a tendency to get the sign for this one wrong, and it's going to throw your whole problem off. So my a is equal to 4, my b is equal to a negative 2, and my c is equal to a negative 7. Okay? Now let's put it in. Negative b, or negative minus 2, okay, plus or minus the square root of negative 2 squared minus 4 times negative 7, all over 2 times 4. All right? We can't have a minus, so that becomes a plus. So I have 2 plus or minus the square root of Negative 2 squared is 4. Okay, and then we have, this is going to be positive, but we have 16 times 7. I don't know what that is right offhand. So 16 times 7 is 112, plus our 4 gives us 116, right? Yeah, 116, divided by 8. Now, is 116 a perfect factor? I don't think so. Close your parentheses. No, of course not. So we have to think, how does 116 factor? Are there perfect factors in there? The answers seem to suggest that there are. So let's take a look here. 116. I'm doing this the old-fashioned way. 2 goes into 116 58 times. 2 goes into 58 29 times. 29. I think 29 is a prime number. So here are my factors, right? My 2 is going to come out. So this becomes 2 plus or minus 2 times the square root of 29 over 8. And then, of course, it's factorable because all 3 terms have a factor in common. So this factors, I'm going to go down here, to 1 plus or minus the square root of 29 over 4. 1 plus or minus the square root of 29 over 4, which is letter A. Okay, so make sure you factor, right? If we had shown the factoring that they both had a 2 in common, it would come out and leave this behind with a 2 outside, which would cancel with 8, right? We skipped that step and just factored it. All right? Okay, let's take a look over here at number 10, because I want to do one more like this with you. It says solve the equation by factoring. The equation is 2x squared minus 5x minus 12 equals 0. Okay, we have a coefficient greater than 1. It makes factoring a little bit tricky. Here's the trick to factoring a problem like this. You're going to take the coefficient of the x squared term and multiply it by the constant. Oops. And that's going to give you a negative 24. Now we need to look at what factors of negative 24 add up to give me a negative 5. And that's going to be, what, a negative 8 and a 3, right? Now we need to rewrite this with these 2 factors instead of this 5. We're basically breaking this negative 5 into 2 pieces. And so I'm going to put the 8 and the 2 together. So 2x squared minus 8x plus 3x minus 12 equals 0. This equation, if we combined our like terms, is exactly the same as this. We have not changed anything, okay? That's the whole point, right? If we change something, then we did it wrong, right? We have to stay the same. So if we combined these like terms, we'd be right back here, exact same equation. But what we're going to do now is factor by grouping, and I'm going to group these 2 parts together. Now, what factor do these 2 terms have in common? Well, they have a 2x in common, right? And that leaves behind an x minus 4. What do these 2 factors have in common? They only have a 3 in common, and that leaves behind an x minus 4. Now, this term and this term have a factor in common, and that's this x minus 4. So I'm going to factor out the x minus 4, and it leaves behind a 2x plus 3, right? 2x plus 3. And now we've actually factored it. If you went back and FOILed this back out, you would end up right back where we started. So now we're going to set each part equal to 0. And here we have x is equal to 4. And 2x is equal to negative 3. So x is equal to negative 3 over 2. They want you to solve the equation. This is enough for me. Okay? The quadratic coefficient times the constant. What factors make up this? And then we rewrite it with those factors. We're basically splitting it apart into 2 pieces, and then we factor by grouping. Okay, that's the trick to a problem like this. All right. Okay, go ahead and finish the rest of these problems, and then I will meet you back here for the next part of section 2. The next part of section 2 begins on page 22, and it's titled Relationships Between Zeros and Coefficients. Again, we have a few definitions here to overlook, or not overlook, but to look over. Okay. And then getting right into relationships between quadratic roots. So it says if we let R1 and R2 represent the two solutions, so root 1 and root 2 of ax squared plus bx plus c equals 0, such that R1 is the plus and R2 is the minus, then R1 plus R2 is the plus the minus, and that ends up reducing down to negative b over a. So if we're adding the two roots together, we are going to get negative b over a. And then it says, additionally, if we multiply the two roots together, it reduces down to c over a. Okay? So it says if the leading coefficient is 1, the following two facts are true. The sum of the roots is equal to the opposite of the coefficient b over a. And the product of the roots is equal to the constant term c over a. So negative b over a for adding, c over a for multiplication. So let's scooch up here to the top of page 23 and look at an example. Write a quadratic equation in this form, which is standard form, whose solution set is negative 1 over 2, comma, negative 1 over 3. So it says from the discussion that we've already had, we know that the sum of the roots is equal to negative b over a, and the product of the roots is equal to c over a. So we can solve for b and a and c using this solution set. Remember, these are the roots. These are my two roots. So to determine, we are going to add these two roots because we know that negative 1 over 2 plus negative 1 over 3 is equal to negative b over a. And we know that multiplying negative 1/2 times negative 1/3 is equal to c over a. Okay, so they've determined that b over a is 5/6. So looking at this, how to actually solve that, we're adding these two fractions. The common denominator is a 6. Okay, so to get this 2 to be a 6, we have to multiply it by 3. So we get negative 3 over 6 plus, we have to multiply this one by 2, so a negative 2 over 6. And that gives us a negative 5 over 6 is the answer. So negative 5 is our b, our a is 6, right? Or these were both negatives. Yeah, both negatives. So I'm not sure. Oh, because remember the solution, I thought it was an error, but remember it's negative b over a, so it actually contradicts or cancels out that negative, and it makes it positive. So here we have a negative times negative, which is fine, and it's going to be 1 over 6, right? Because 1 times 1 is 1, 2 times 3 is 6, and so that's how they got to this, right? So our negative 5 over 6 actually is a negative twice, right? Because this negative is part of the equation, and that negative 5 is part of the term, so they cancel each other out. So b over a is 5 over 6, c over a is 1 over 6. If you do this work and your a's are different, then you've made a mistake somewhere, okay? So then they've taken this equation and they've divided all of the parts by a to get the x squared by itself, okay? And now we have our b over a and our c over a. But honestly, then they had to remultiply it out. That seems a little silly, when we could have just gone from this to this, okay? Because we know that a is 6, we know that b is 5, and we know that our c is 1 from this set of equations here. So I don't know why they did this part. It seemed like a little too extra. We could have just gone right to here. And that's our answer, okay? So let's not make things harder than we need to. But also let's take a look at this next example. It says 1 root of the equation 3x squared minus 12x plus c equals 0 is 2 plus the square root of 3. Find the other root and the value of c. So here they started by dividing the given equation through by 3. They want their x squared to be to have a 1 coefficient. So they ended up with x squared minus 4x plus c over 3 equals 0. Now, since our root 1 is 2 plus the square root of 3, and the two roots added together gives us a negative b over a, we can rewrite that so that root 2, because that's what we're solving for, is equal to negative b over a minus root 1. And then they substitute in our b over a, because our b is 4, and our root is, our a is 1, right? So this would have been a negative 4, but we're taking the negative of the negative. So positive 4 minus root 1, which is 2 plus the square root of 3. And so we get as our answer 2 minus the square root of 3, because we have to distribute that negative through. So now we have our second root, 2 minus the square root of 3. And then they can solve for c by going to the multiplication part. Root 1 times root 2 is c over a, right? And so they've put in root 1, or they've solved for c, which is root 1 times root 2 times a. So they have root 1 times root 2 times a, and that whittles down, reduces down to 3. Because remember, we have a sum and difference binomial here. You just square the first term and you square the second term. So the answer is 3 for C. I don't see that they actually rewrite the equation, but then it would be 3x squared minus 12x plus 3 equals 0. That's the equation now with the C filled in. Okay? Definitely going to do one of these find the second root problems in the homework. But for now, let's continue on at the top of page 23 in the second column. What is the discriminant? The discriminant is this expression that is underneath the square root sign, okay? And the discriminant allows us to know how many real roots and a quadratic equation actually has. So it says here that should this expression, this discriminant here, be a negative number, then no real roots exist, right? That's not going to be a real number because we can't have there is no real number that's a negative square root. If b squared minus 4ac equals 0, then the function has two equal real roots. So this is a little bit misleading because it has two equal real roots. So when you look down here, it says there's only one root, and you're like, wait, it just said it had two. But because they're equal, they're both 3, let's say, it's technically just one root because both of the two roots are both the exact same number. So it's here, that's why they have it listed as one root. If b squared minus 4ac is greater than 0, then the function has two real unequal roots. So roots that aren't going to match up, like these two roots here, right? For this one, it had two unequal real roots. So its discriminant must have been greater than 0. So negative, no roots. Equal to 0, 1 technically. Here's the summarization. Greater than 0, 2. Okay? All right, let's take a look at this example. Without solving the equation, because that's not what they're asking, they want you to determine the nature of the root of the zeros or the roots. They want to know how many they're going to have. Okay, so remember, we still need to list our A, B, C. Our A is 3, our B is negative 2, our C is a negative 7. So our discriminant is b squared minus 4ac. So negative 2, the quantity squared, minus 4 times 3 times negative 7. Without even figuring out that it's 88, you can see here that this is a positive and this is going to be a positive number. And when I add two positive numbers together, it's going to be greater than 0. So I know that there are two unequal real solutions, or just two solutions would be fine. You don't actually need to know that it's 88. We can use our judgment and see this is positive and this is positive. My answer is going to be a positive answer. I have two real solutions. Okay? let's turn the page. Okay, at the top of page 24, now we're looking at graphs of parabolas. Like they said earlier, parabolas look like this. Sometimes they go upside down. This section's not going to cover them facing the sides or anything, but technically I suppose they can. So they want us to consider this graph as y equals x squared, okay? I feel like the easiest way probably to graph points of a parabola is, yes, to find the roots, but also just to put in a couple of points, since this specifically is a fairly simple graph, and then we can have a few points to plot, okay? Looking at the one in the bottom of the first column, it says the opening in a parabola will vary depending on the value of a, which is the coefficient of the x squared term. The values of b and c move the graph to another position, or translate it is what that's called, on the coordinate axis as shown. Also, if a is less than 0, then the graph is inverted and opens down. So if you have a negative, and that graph is up here, if you have a negative coefficient to your x squared term, then your graph is going to open down. Okay, so looking at example here on page 24. Draw the graph of the function y equals x squared plus 6. So it says to use the discriminant. A is 1, B is 0, C is 6, and they solved their discriminant and it's going to be negative, right? Because 0 minus a number is negative. And so it tells us the graph has no points on the x-axis, okay? Now, it's asking us to draw the graph, and this example doesn't actually go well into how the heck do I draw this graph, okay? But let's take a look at, oops, sorry, bumped the camera. Let's set up our coordinate plane. Let's actually graph this graph like they've asked us to, okay? We always want to know what our x is at 0. That doesn't always mean our x is going to be at 0, or that it's going to cross like here, right? It doesn't cross 0 at the vertex. But since we're not delving deep into the formula for a parabola right now, let's just do the basics. So when x is 0 in this equation, I have 0 squared plus 6. My y is going to be at 6, okay? Which is clearly shown here. But let's get another set of points, because it's always important to have at least 2 points. I mean, you could easily just whoop whoop, but that doesn't really show what the parabola's actual shape should be. So let's look at x equals 2, okay? When x equals 2, then I have 2 squared plus 6, which is 10, right? But because a parabola swoops around like this, then I know when x is also a negative 2, and so usually I just write plus or minus 2 because the answer is the same, right? We're squaring it, but for now I'll just do it this way. So I have negative 2 squared, which again is, or plus 6, which again is 4, right? 2 squared is 4, negative 2 squared is 4, plus 6 is 10. They are both at the same point, and you can see that right here. That is enough for you to draw and have a good shape. Right here is your starting point, and to have a nice shape for this parabola. All right, so while the discriminant is great and all, it doesn't actually help us graph this function, okay? At least not this particular one. So here is how you would do it. Here's, from what we've learned so far, this is the easiest way. Okay, so let's take a look at the top of page 25. For number 25, it says draw the graph of the function y equals x squared plus x. Again, they solved the discriminant because our a is equal to 1, our b is equal to 1, and our c is equal to 0. Okay, we have 1 squared minus 0 because you're multiplying by a 0, so it's gone. So our discriminant is 1, so we have 2 points on the x-axis, right? But again, that doesn't draw the graph for us. I'm not sure where we lost our way here for this. So my x and my y, right? This is basically x times the quantity x plus 1. is what this factors down to. But let's just look at our x and our y. Again, I always like to start at x equals 0, even though technically that's not our vertex this time, right? But when x equals 0, then I have 0 squared plus 0, which is 0. All right? And that's where I'm at right here. 0, 0. Now, if that was the only point that I decided to find, I would graph this parabola completely wrong. Okay? Because also I have what right here, right? When x is -1, I have -1 squared plus a -1. Or this is a +1 minus 1 gives me 0. Now, the only way to figure that out is to kind of fumble through this problem, okay? And sometimes it just takes trial and error since we haven't gone into exactly how an equation for a parabola is set up just yet. So then I'm going to try +1, right? Plus, remember how I told you I like to do plus or minus 1? Plus or minus this, plus or minus that? Well, I'm going to have to do it a little bit different this time because my plus and minuses don't line up. 1 squared plus 1 is 2, okay? My line of symmetry is technically this like halfway point. So I know that if I am at x plus 1, y plus 2, and I am a 1.5 from the line, if I go a 1.5, then I have another spot on my graph. So that's, if I was graphing it, these are all the points that I would figure out. Yes, I wouldn't know exactly where the vertex is, but I could just assume it when I'm drawing my shape in. Now they go another part here, right? I'm pushed over though, so I'm not exactly falling on the axis, so my numbers aren't going to line up this time. I'm going to have to do one at a time. So then I would do 2, right? 2 and -2 aren't going to be the same thing. 2 is over here, -2 is this point here, okay? So you might have to, on some of these, you might have to find a few extra points. Okay, let's take a look at the next example. We're going through these kind of slow, but I want to make sure we are understanding how to actually graph these since they say draw the graph, okay? It says draw the graph of function y equals -2x squared. They solve for the discriminant, okay, and get a 0. That tells us the graph has one real root. Fantastic. That doesn't really help us out too much in graphing this function. So x, y, I like to start with my x being 0, right? If my x is 0, then I have -2 times 0 squared is 0, okay? Since this point, since I know from the discriminant that I only have one real root, this is my one real root, thus it's my vertex. Hallelujah. Now let's look at plus or minus 1, okay? Plus or minus 1, forgot about my -2. -2 plus or minus 1 squared, doesn't matter. The plus 1 squared is 1, -1 squared is 1. So my answer is -2. And that's clearly shown here. That's really enough, but let's take a look at plus or minus 2. So I have -2 times plus or minus 2 squared, both cases are 4, times a -2 gives me a -8. Okay, right here, this negative tells me that my graph is going to open down, but if you weren't sure, figuring out these points tells you, oh, I am at +2, -8. I'm at -2, -8. My graph must open down. All right? Okay. Now that they asked us to graph 3 graphs without actually teaching us how, let's take a look at finding the vertex and the axis of symmetry. It says the quadratic function may be graphed by finding the vertex. Yeah, it's a very important part of this graph, okay, of the parabola curve, and knowing the axis of symmetry. Again, very important, because technically if you knew the axis of symmetry was the y-axis, you would only need to find +1, because then you would know that complete opposite of that is another point. And then +2, and go across, there's another point. That's what symmetry is, right? If you folded this parabola on this y-axis, the points would match up. It says the axis of symmetry is the line that divides a parabola in half. The form y equals a times x minus h squared, the quantity squared, plus k, is the general form for a parabola, okay? For a parabola that could be anywhere on the coordinate plane. The value h and k is the vertex, h comma k, all right? Now be careful when you pull out your h, because that negative sign belongs to the equation. So if this says x plus a number, that tells me that that number is actually negative. So you take the opposite of h. Whatever this h is, you take the opposite sign. Okay, so that's the vertex. X is always the h, and y is always the k. All right? Well, usually this is written over here, y minus k, but k is always the y value, h is always the x value, okay? So let's take a look at the example, top of page 25, second column. It says, draw the graph of the function y equals x squared by finding the vertex and the axis of symmetry, okay? They want us now to write this in this form, right? This new form we just talked about. It's fairly unnecessary because y equals x squared. It's definitely at the axis, or at the origin point, because I don't have anything else. I don't have a plus x. I don't have a plus 6, right? There's nothing else to move it. Remember, over here at the bottom of page 24, it says that b and the c are what move the graph to a different place. If I don't have a b and c, which I don't have here, then it's just at the origin point. So this is a bit of work that's unnecessary. Our vertex is at the origin. Our axis of symmetry is the y-axis, okay? Our line of symmetry is the y-axis, or where x equals 0. All right, let's take a look at another example. It says, draw the graph of the function y equals x squared plus 2x. Now I actually have something that's going to move my graph, okay? They want us to find the vertex and the axis of symmetry. To solve this, we have to actually complete the square. Now, maybe you remember how to complete the square, maybe you don't. Let's take a look at how to go through those steps together. Okay, completing the square is not too challenging, but if you haven't done it in a while, maybe you don't really remember how. So y is equal to x squared plus 2x. I'm going to, yes, I rewrote it because I'm going to be adding something here, right? We take this middle term, the linear term, the x coefficient, and we divide it by 2. That gives me a 1. I put that 1 in a box, and then I square it. 1 squared, of course, is just 1. So I'm adding 1 here, but because I'm adding 1, I'm changing the equation, so I also need to subtract 1, and there's not a lot of room. They did it right here, okay? They added the 1, which belongs to these three things, are now a group together, and then they subtracted the 1. That's the only way to keep the equation the same. But to figure out what to add and subtract, this is the steps you take, right? You take the linear term, divide it by 2. I put it in a box because that's what I need later on. You square it, and that's a 1. This is the 1 we added. This is the 1 we subtracted. Now, these three terms together are a perfect square trinomial. And so that changes then to x plus what's in the box, plus 1, the quantity squared, minus 1, because remember our minus 1 is sitting out there, and that's what they have here. All right, so that's how we complete the square. Now it is in the correct form, right? Now we have it in this, this form here. And we can find our h and our k. So our h, remember, is the x value, is the opposite of this. So it's a -1. And our k is also a -1. So that is our vertex. And I'm abbreviating, okay? That is our vertex. And our axis of symmetry is equal to h. And our h is a -1, so that is our axis of symmetry. Then to actually graph this, right, now you know where your vertex is, and you know where your axis of symmetry is. I like to write it in as a dotted line. Now you still have to plot your points. You still need to make your chart and figure out your points. Since you know your axis of symmetry, I would do x is 0, right? 0 is 0. You could put your 0 point in here because this is your axis of symmetry. You were 1 block away, so you go 1 block out, and there's your next point. And then I would do a 1. And 1 squared plus 2 times 1 is 3, right? This is 1 plus 3, or plus 2 is 3. So I would go to 1, 3. I am 2 blocks from my axis of symmetry, so I go 2 blocks past it, and now I can draw my parabola. Okay, so even though we did this, we found the vertex, we found the axis of symmetry, we still have to do this to figure out the shape of our parabola. Okay, it's just part of how you do it. I'm not sure why they aren't going into that detail yet, but that's what you have to do. All right, let's turn the page. All right, looking at the example at the top of page 26, it says draw the graph of the function y equals 3x squared plus 6x plus 1. Finding the vertex and the axis of symmetry. Okay, we still have to complete the square. That is part of being able to solve this. Okay, so this one's a little bit different. Let's see how they started here. So y equals 3x squared plus 6x plus 1. They've kind of set these two pieces aside. Okay. And then they have factored out the 3. So y equals 3 times x squared plus 2x. I'm leaving a space, plus 1, because that space is where my term is going to go when I complete the square, right? Again, my linear coefficient is 2. 2 divided by 2 is equal to 1. 1 squared is 1. So I'm going to add 1 here, because that's what I need to do. But I also need to subtract the same amount. The problem with this one is I put a 1 in here, but actually I'm adding a 3, because remember this 3 out here would, if I distributed that through, that would make that a 3, right? So because I added 3, I need to subtract 3, okay, which is what they've done here, but I feel like they haven't gone super clear into how they did it. So now I have y is equal to 3 times, this is a perfect square trinomial, so it's going to be x plus 1, that's what's in the box, the quantity squared. And then I have 1 minus 3, which becomes a -2. Now here is my form, and I can use my hk, right? And see that my h is a -1, and my k is a -2. The axis of symmetry is at -1. And so that gives me this point and my axis of symmetry, but that's all. Again, I have to do the next step. If I am graphing this, if I had an empty graph, I can't just put 1 point and the line of symmetry and then know what the shape of this is going to look like. It's not possible. So since I started at -1, I'm going to go to 0. And when x is 0, I have 3 times 0 plus 1, the quantity squared, minus 2. I'm trying not to schmutz into other things too much. But this is a 1, right? 1 squared is 1 times 3 is 3 minus 2 is 1. So I know that I'm at 0, positive 1. That's 1 place away from the line of symmetry, so I go 1 place farther, and I can put a dot. And now I'm going to do the 2. 3 times, not 2, sorry, I'm going to do 1. X equals 1. 1 plus 1, the quantity squared, minus 2. 1 plus 1 is 2, squared is 4. 4 times 3 is 12, minus 2 is 10, which is probably why they didn't plot another point. They didn't give themselves enough room. On your work, when I give you a graph, I would have put my line of axis down here, my x-axis. That would give me plenty of space to go up, right? But at least this tells me I'm at 1, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is probably like here, right? That tells me how narrow my parabola truly is. And it's super narrow because of this 3. All right? So it says, notice that the vertex becomes either the lowest or the highest point of the graph. These points contain the extreme values of the function called the maximum or the minimum values. Over here, determining if the inverse is a function, it says consider the inverse of a quadratic equation, f of x equals x squared. So the inverse of f of x would be plus or minus the square root of x, right? We switched our x and our y and solve for y, so we end up with y equals plus or minus the square root of x, which is graphed like this. All right, but it says notice that the inverse does not qualify as a function. However, if we took just the positive parts, we could at least graph the information and see it. All right, not super, I mean, I'm sure there are places that this is useful, but they are just covering it real quick, so I don't expect us to see it too much going forward. All right, let's take a look at some of these problems together. We're going to start with number 14, and it says 1 root of x, or 2x squared plus 8x plus c equals 0, and that root is 1 plus the square root of 5. What is the other root? Now remember, root 1 plus root 2 is equal to negative b over a. And so we are solving for root 2. So root sub 2 is equal to negative b over a minus root 1. Okay. Now, what is b and what is a? Well, b is 8 and a is 2. So root 2 is going to be minus 8 over 2 minus root 1, which is 1, oh my goodness, 1 plus the square root of 5, okay? Or this is a negative 4 minus 1 minus the square root of 5, which equals negative 5 minus the square root of 5 is my second root. Negative 5 minus the square root of 5, letter D. All right, without solving, number 15, without solving the equation, what is the nature of the roots? So they're asking for the discriminant. I'm not sure why they can't just use the word discriminant. Of the roots, x squared minus 2x minus 8. Well, my a is equal to 1, my b is equal to a negative 2, and my c is equal to a negative 8. And remember, the discriminant is what's underneath the square root bracket, right, which is b squared minus 4ac. So I have negative 2, the quantity squared, minus 4 times 1 times negative 8. Now, I am not solving for this number because that's not what they're asking. They want to know the nature of the roots. This is going to be positive, and this is going to be positive. I have a positive answer. It's going to be A. All right, we don't need to get into what exactly this number is. That is unimportant when we're talking about the nature of the roots or the discriminant. We need to know, is it greater than 0? Is it equal to 0? Is it less than 0? This is greater than 0, so we have 2 real roots. Let's do another one of those, number 16. Without solving, what is the nature of the roots? So my a is equal to 1, my b is equal to 3, my c is equal to 9. I can tell you right now, probably going to be negative, because I don't have a negative to offset my 4ac, okay? So I have 3, the quantity squared, minus 4 times 1 times 9. This is positive But this is negative, and since this is bigger, right, negative 4 times 9 is larger than 3 squared. It doesn't matter how much or by how much. This answer is going to be a negative answer. So that tells me that I have no real roots, because I cannot have a negative real answer underneath a radical sign. Okay? We don't need to figure out what the actual numbers are. If you want to, you can, but it's a step that's unnecessary. All right? All right, let's turn the page. Looking at problem 18 at the top of page 28, it says, choose the graph of the function f of x equals 2x squared. Okay, I know right off the bat that it's not a, because I don't have a b or a c part here to move this off of my origin point. Okay, I also know that it's not b because it's not the square root of something, and that's what this looks like. So then I need to decide between C and D. Now, from our examples that we did, we knew that when there was a 3 here, that it made our parabola very narrow. So I'm going to say that our answer is D, right? Or put a check mark in there, I guess. Because this is very wide. That would be the case if there was a fraction in front of our x squared. But because we have a 2, our parabola is going to be more narrow. Okay, so let's look at 19. F of x equals 1/4 x squared. Okay, so again, it's not opening down because this is a positive. It's not going to be away from the origin point because I don't have anything over here to move it away from the origin point. And as I just alluded up here, the fraction actually makes the parabola wider. So this time it's A. Our answer is A. All right, let's do one more of these together. Choose the graph of the function f of x equals 2x squared. Okay, well, or sorry, the square root of 2x. Okay, it's not negative. It has nothing to move it away from the side. Technically, to graph these real numbers, we can't do both. Technically, these under here wouldn't be real numbers, so our answer is B. Right? Because anything less than 0 doesn't actually have a real solution. So the answer here is B. All right, so keep working on those. Let's take a look at number 23 together. It says choose the graph of the function f of x equals negative 3x squared. Okay, I don't have an A or a B, so it's definitely not this one, right? It's definitely not this because this is a very special case. So we have to look, is it A or is it C? Well, this is a negative 3, which tells me that my graph opens down, so it's going to be C. Okay? Just some things we have to get used to looking at. Let's take a look at number 24. Choose the graph of the function f of x equals x squared minus x. Now this time, it is going to move off of my origin point. So I know it's not this or this, because this negative x here is going to move us off of our origin point. Because these are negative, we know it's going to open down. So D has to be the correct answer. Okay, let's look at one more of these together. Find the axis of symmetry for the equation y equals x squared plus 4x minus 6. Okay. To do this, we have to complete the square, and completing the square only involves these two parts. So 4 is my coefficient of my linear term. So I'm going to take 4 and divide it by 2. That gives me 2. I'm putting it in a box. 2 squared equals 4. That's what I'm adding in. So now I have y is equal to x squared plus 4x plus 4 minus 6, because that was part of our equation, but we also have to minus, since we added 4 here, we have to subtract it here. Now we have this perfect square trinomial, which is going to be x plus 2, that's why I put the box around this one, the quantity squared, minus 10. So what is our axis of symmetry? It's our h, and in this case, our h is a negative 2, comma, negative 10 would be our vertex, right? They didn't ask for that. But Our axis of symmetry is this h, so it's at x equals -2. Taking a look at number 26, we have 3x squared plus 18x plus 30. They want us to find the vertex, so we need to complete the square, which involves these two numbers. They have a factor in common, so we are going to factor that out, which is the 3. Well, we don't want to factor out everything. We want our coefficient of our x squared to be 1, so we're going to end up with x squared plus 6x, we're going to leave a space, plus 30. Okay? 6 divided by 2 is 3. Put it in a box, square it, 9. I'm going to add 9 here, but I'm not really adding 9. I'm adding 27, right? 3 times 9 is 27, so I'm subtracting 27. Now, this is a perfect square trinomial, so y is equal to 3 times x plus 3, that's what's in the box, the quantity squared, and then I have over here plus 3. 30 minus 27 is 3. So what is my vertex? Is my h, comma k. Opposite of this, so -3, comma 3. -3, comma 3 is letter A. All right, completing the square, finding my h, comma k. All right, good job. Go ahead and finish the rest of this part of section 2, and then we will go on to the next part. All right, the final part of section 2 begins here on page 31, and it's called quadratic inequalities. It says here that these expressions can be graphed the same way in which we graph relations defined by linear inequalities, meaning we're going to graph our quadratic equation. Sometimes it's going to have a dotted line, sometimes it's going to have a solid line, and then we have to shade an area. Don't forget the shading part. It's important, okay? That's what makes it an inequality. It says an easy way to determine which region to shade is to check the point in each region to see whether it satisfies your inequality. Now, after all this time, for example, here on page 31, they say graph y is less than x squared plus 2. They finally actually found points, right? They set it up, found their vertex, their line of symmetry, fantastic, and then they actually had to plot points because that's the only really way to graph this, okay? Because it's a less than, we know it's going to be a dotted line. And usually a less than is underneath the line, right? If we were standing on this line, we'd be inside the bowl. A less than would be under our feet, okay? Now, to double check that, which is always very important, is to choose a point. And they chose the point -2, 0. So -2, 0 right here. You could have chosen the point 0, 0 because you've already graphed this. You can see that that also would be an easy point to choose, but they chose -2, 0. So they put it into the equation. Is 0 less than -2 squared plus 2? The answer is yes, so that is the part that we shade. Okay? Please make sure you're shading your graphs. Let's turn the page. All right, at the top of page 32, it says here, using graphs to identify quadratic inequalities. Our example is graph x squared minus 2x minus 3 is less than or equal to 0. It says here that there is no y, but we can replace the y for right now with the 0, okay? But we have to factor this or complete the square or however you want to determine, but we need to get it into our parabola form. So what they've done here is factor, and they found two places where this parabola crosses the x-axis. Now again, while that's useful, it's not always enough to graph an equation, but because this is an inequality and this has to be less than or equal to 0, here's what the graph looks like if you had plotted all your points and completed the square and found your vertex and your whatever, right? This is what the graph would actually look like. But the shading part is different because we want the solution where this is less than or equal to 0. Remember, that was the original part. We replaced it so that we could complete the square and graph it. Okay, it's a solid line because it's less than or equal to. But for the shading, it's only where it is less than or equal to 0. And the only place that y is less than or equal to 0 is between these two marks. Right? Looking at our graph, the only place that y is less than or equal to 0 is when x is between these 2 points, which is why they've shaded it like this. Because anywhere in between this point, even though it's really only down here, right? I mean, y in the upper part is not going to be, like if you shaded it like that, I would be fine with that because that's true, right? There is no positive y, or sorry, there is no y less than 0 up here. So personally, this to me is shaded more properly than this, but I'm not going to fault you either way. Okay, but that's what they're trying to show here. They just took the graph away, but it makes it a little bit more understandable to me with the graph. I like to see things that I'm dealing with. All right, let's take a look at some of these problems. Most of these are just like choose the graph that fits the situation. So choose the correct graph for the following set of points. Y is greater than x squared. All right, so first of all, we know that this x squared, y is greater than x squared, starts at the origin point. We've already talked about this, so we know it's not A or B or C, and is definitely D. Now, because y is greater than, it should be a dotted line, and it should be shaded inside, okay? If we're walking on this line inside the bowl, it would be above our head, which would be inside the bowl, okay? That one was pretty easy. Let's take a look at another one. Choose the correct graph for the following set of points. Y is greater than or equal to x squared plus 3. All right, this plus 3, because it's the constant, tells me that I'm going to be up 3 points from the origin. I don't have this is our C number, right? I don't have a B that would push us side to side. So I know it's not this, and it's not this, and it's not this, okay? I'm up 1, 2, 3 points. I'm greater than or equal to, so it's a solid line shaded on the inside. My answer is C. Okay. Choose the correct graph for the following set of points. Y is less than or equal to 3x squared plus 2. Okay, again, this plus 2 is going to push us up 2 points. So it's not this and it's not this. This 3 is going to make it narrow. That's not really the point. What we need to look at now, because these graphs are very similar, is this less than or equal to. Less than or equal to tells me it's a solid line. But less than tells me if I'm walking on the line, which means I'd be inside the bowl, I'd be shading under my feet. Now you can test out the 0.00 if you want on both of these. Okay, let's do that. Is 0 less than or equal to 3 times 0 squared plus 2? So is 0 less than or equal to 2? Yes. So this point is in, so it's A, not C. All right, so that's what we're doing here. We're going to do one more together, and then we'll be done. Choose the correct graph for the following set of points. Y is greater than or equal to 2x squared minus 5x plus 1. Okay, a lot of movement going on here. Okay, so we're definitely not on the origin point. Not sure why it keeps giving us a circle, technically 2 circles. It's interesting. Y is greater than or equal to tells me it is a solid line. All of these are solid lines. That's great. But the greater than tells me I'm going to be in the bowl. So it's definitely not that one. All right. Now, just looking at this, I'm not 100% certain which is which. So we have to do a little bit more work here. So we're going to set it up as an equal for now, just to get the general points. So y is equal to 2x squared minus 5x plus 1. Okay. they want us to set this up. We are going to have to complete the square. This completing the square is going to be a little bit more challenging because our 2 and our 5 are not factors of each other. I need to divide out this 2. It's going to leave an x squared minus 5 over 2x, right? And then I'm going to leave a space for my other term that's going to go in there. I divided both of these parts by 2, right? So now my linear term is a negative 5 over 2, and I'm dividing that by 2, or timesing it by 1/2, okay? And so that's going to give me a negative 5 over 4, putting it in a box, and squaring it gives me a positive 25 over 16. So I'm adding 25 over 16, but I'm also subtracting twice that much, 50 over 16, okay? And now, like I said, this one's a little bit messier. I still have a perfect square trinomial here, so y is going to equal, make sure I'm on the page, 2 times x minus 5 over 4, because that's what's in our box, the quantity squared. And then what is this? Well, this is 16 over 16, which is my 1, minus 50 over 16, okay? So what is that, 34? A negative 34 over 16? Yep, we can reduce this because they both have a 2 in common. So this becomes, what, a negative 17 over 8? Okay, minus 17 over 8. Now, you might be thinking, what the heck? That is crazy. And it is. Our vertex, because that's what we're trying to solve for here, so we can figure out which one of these is our correct spot, right? Our vertex is going to be at positive 5 over 4, comma, negative 17 over 8. Now, positive 5 over 4 is technically what? 1 1/4, okay? Negative 17 over 8 is just over 2, which puts us right here at A, not B, okay? So this one was a little bit more work, but we needed to figure out where our vertex was so we would know between these two which is the correct one, okay? The only way to do that was to complete the square. This completing the square was super messy, but nothing we can't handle. All right, there's a couple more problems I think on the next page. Oh, yes, go ahead and work through those. You do not need to do this self-test. I will, if you're in my class anyway, I will provide a test that encompasses both of these sections for you to work on. As always, if you have any questions, concerns, or need help with anything, please do not hesitate to contact me. Otherwise, until next time.